All right, here we're looking at a square in the coordinate plane, and we're asked to prove that it is, in fact, a square. And we've actually kind of done this before, but we'll go over it again. To be a square, it has to be, of course, a quadrilateral, 4 sides. But specifically, it has to be a quadrilateral with all 4 sides being the same length and all 4 angles being right angles. And there are some shortcuts we could take in proving that this shape is a square, but I'm just essentially going to lay it out. We'll do calculations to show that that the 4 angles are right angles and that the 4 sides are all the same length. And so we're just going to do find AB. That's this length here. So if I were to, we'll use Pythagorean theorem. And we've got up to and over 1, 2, 3, 4. So 2 squared plus 4 squared is c squared. Let's see, 4 plus 16 is c squared. 20 equals c squared. Square root of 20 equals, I'm going to write this as AB, because that's what we did find. I suppose I could have written AB squared all along. Find BC. Find BC. And look, and it's 2 and 4 again. So 2 squared plus 4 squared is BC squared. So 4 plus 16 BC squared, 20 BC squared, and square root of 20 is BC. Okay? And I could go through the same process with CD and DA, or if you could find some way of explaining how you know that all 4 sides are the same length without doing all the calculations, then I would encourage that. But we could always resort to just doing the calculations. So part 1 of this proof is to show that all sides are congruent. Okay. The second part would be show all angles are right. Okay. Now in the coordinate plane, if we're showing that all the angles are right angles, what we're showing is that the sides are perpendicular, or they're perpendicular lines or segments. And to do that, we have to look at their slopes. Okay. So we want to show that the slope of AB is the negative reciprocal of the slope of AD. And so let's see here. So I'd find slope AB, and I'm not going to drag the slope calculation out. We're doing our change in y over change in x. Our change in y is going to be, remember, end minus start equals change. So for AB, we'll imagine that we're going in that direction there. It doesn't matter as long as I'm consistent with both my change in y and my change in x. So we have 9 minus 7. And then for my change in x, 5 minus 1. And that gives us 2 over 4, which simplifies to 1/2. Oh, a lot there. 1/2. Next, we're going to do the slope of BC. Slope of BC. So I've got my change in y over my change in x, and this time we'll go this direction, although it doesn't really matter. So change in y is 5 minus 9, end minus start equals change. Change in x is 7 minus 5. So that is negative 4 over 2, which simplifies to negative 2 over 1, which really is just negative 2, but I wanted to illustrate that negative 2 over 1 is 1/2 flipped upside down and with the sign changed. Okay. Now I could go ahead and do the same to calculate the slope of CD and AD, and I'll get the same numbers again, and I can show that the slopes of adjacent sides, there's a good word for us, adjacent is next to, AB is adjacent BC, so we could show that the slopes of adjacent sides are negative reciprocals. That would be enough to prove that the 4 angles are right angles, and that all 4 sides are the same length. And that would show that this is a square. And again, we're doing this all with calculations. I suppose if we needed to, we could always use the distance formula instead of Pythagorean theorem if we didn't have the graph in front of us. But we have the graph in front of us, so I think it's okay if we go ahead and use just Pythagorean theorem. We do have our slope calculations over here to show the slopes. So again, slopes tell us that that adjacent sides are perpendicular, meaning that they meet at right angles. And the Pythagorean theorem calculations show us that all 4 sides are the same length, and therefore the shape is a square.